Hello everyone, I'm Blitzlingat from the Peer Tutor Society and I'm going to teach you how to apply the derivative rules in finding the derivative of a function. So the first rule we want to know is the constant rule. So basically what this means is that the derivative of a constant by itself is just zero. That's it. So I'll show you what I mean. So for example, number one, we have y is equals to 5. And since 5 is just by itself, the derivative of 5 should be 0. So y prime is equals to 0. Okay. And let's have another example. F of x is equals to pi. Since pi is by itself and the derivative of any constant is 0, and remember pi is also a constant, then the derivative of pi is just 0. So f prime of x is equals to 0. All right. Now, how do we solve this problem? So f of x is equals to 5x raised to 18. So the power rule. So the so first things first, we want to solve what is right here. So according to the power rule, what we can do is that we can bring the exponent down first and then subtract it by 1. And then after doing this, what we can do now is multiply it by the constant that we have here, which is according to the constant multiple rule. So here's how we can do it. So first of all, let us first apply the power rule to x raised to 18. So f prime of x is equals to 5 times 18x raised to 17. So what I did is I brought down 18 and then subtract the exponent by 1. Now after that, what we can do now is multiply 5 with 18. So f prime of x is equals to 18 times 5, and that is just 90 x raised to 70. And that's it. That is our final answer. So now let's have another problem. What if we have multiple terms? So we have f of x is equals to 4x raised to 4 minus 5x minus 3. So what we can do is just we can solve each of these terms separately as if they are just one problem, and then we can combine them together again. So in this case, we have f prime of x is equals to, so now we have 4 times, bring down the exponent 4. So 4 times 4x raised to 3, because 4 minus 1 is 3. So the exponent is now 3. Now we have 5 times x. But since this is just 1, we brought down 1. And then we subtracted 1 by 0. So this is just going to be 1 minus 0. Remember, a derivative of a constant is just 0. So now f prime of x is equals to 4 times 4, 16x cubed minus 5. And that is our final answer. So if you got confused by what happened here, okay. So x, this is just the same as x raised to 1. However, we brought down 1, right? So 1x, and then subtract 1 by 0. So sorry, subtract 1 by 1. So that becomes 0. And since any number raised to 0 is just 1, so now we have 1 times 1, and that's just 1. And that's why we have the 1 here. Okay. Let me erase that. And now, last problem. For this rule, y is equals to negative 1/2 x raised to 4 plus 3x raised to 5 over 3 plus 2x. Okay. So again, we can just separate this problem together. We can just separate the problem. So let us solve first for the derivative of this first term. So now we have y prime is equals to 1 - 1/2 times 4 raised to 3. Again, the power rule. That's why we brought down 4 and then subtracted 4 by 1. So we have 4x raised to 3. Now we have 3 times, bring down the 5 turns. So we have 5 turns. Then subtract that 5 turns by 1. And then we have 5 over 3 minus 1. That's around 2 turns. Plus 2. Again, this x is just 1 because we brought down the 1. And then 1 minus 1 as the exponent is just 0. So 1 times 1 is 1. So now we have 2. So let us multiply these numbers together so that we can simplify our final answer. So -1/2 times 4 is around 1/2 times 4. That's 2, -2x³ plus this one, I believe, is just 5. So 5 over 3 times 3 is around 5. X raised to 3 plus 2. And that is our final answer. Okay, so we have the product rule this time. So here is the definition of the product rule. But basically, what it means is that given two functions that are going to be multiplied together, what we can do is that we can just keep f of x as it is, okay? Then get the derivative of the g function. Then for the other side, it's just the same thing. We can keep our g of x as it is, then get the derivative of the f of x function. So let me demonstrate an example where you can see the product rule in action. So number 1, we have y is equals to -x³ times 3x raised to 4 minus 2. So one way to solve this is to simply distribute the -x³, but that's not an application of the product rule. So I mean, it's fine to do it, but I'm just here to show you how the product rule works. So in this case, y prime is equals to, so let us keep our f of x function as it is. So it's this one. Then we get the derivative of this one this time. So in this case, the derivative of that function is 12x³. And since -2 is a constant, we're just going to make it 0. So there we go. Now for the other side, let us get the derivative of this function. So that is just -3x² rather. Okay, then we can just copy this one. So 3x raised to 4 minus 2. After that, we can now multiply the things that we did together. So -x³ times 12x³ is just -12x raised to 6. Then here, distribute this -3x² into the parentheses. So -3x² times 3x raised to 4. That's around -9x raised to 6. Then -3x² times -2 plus 6x². Okay, so y prime is equals to -12 minus 9. So that's around -21. So -21x raised to 6 plus 6x². And that is our final answer. Okay, let's have another more complicated example. So let's have number 2. Y is equals to -2x raised to 4 minus 3 times -2x² plus 1. Okay. So again, let us first just copy this. So y prime is equals to negative 2x raised to 4 minus 3. Then multiply it by the derivative of this other function. So we have negative 4x, and that's it. Now, let us get the derivative of this one, of this part. So it's going to be negative 8x cubed, okay, times, just copy this. So negative 2x squared plus 1. Now, after that, we can now just distribute into the parentheses. So y prime is equals to, what is negative 4 times negative 2? That's around positive 8. So 8x raised to 5 plus 12x plus negative 8x cubed times negative 2x squared. That's around positive 16x raised to 5 minus 8x squared, x cubed rather. Then add like terms again. So we have 8 plus 16, that's 24, x raised to 5 minus 8x squared, x cubed plus 12x. And that is our final answer. Okay, then we have our last example. This time we have y is equals to negative 2x raised to 4 plus 5x squared plus 4 times negative 3x squared plus 2. So the product rule kind of makes your life easier because instead of multiplying these two by hand, you can just use the rule to make it, faster to solve it. So in this case, again, let us just copy this part. So that would be negative 2x raised to 4 plus 5x squared plus 4. Then get the derivative of this one. So we have negative 6x plus, get the derivative of this part naman. So that would be negative 8x cubed plus 10x. Then just copy this. Just copy that. So we have negative 3x squared plus 2. Okay. Now, normally you would multiply these two together, but some professors would be okay with just having this part. So basically, some profs just you know do not want you to have a hard time. So it's okay if we leave it just as it is. So in this case, let's just make our lives easier by multiplying this together. So we have y prime is equals to, well, let's just distribute the negative 6 into the parentheses. So we have negative 6 times negative 6 times negative 2x raised to 4, that's around 12x raised to 5 plus negative 6 times positive 5, that's around negative 30x cubed. Let me double check. So 6 times 5, that's 30, right? Then negative 6 times 4, that's around 24x plus 8x cubed plus 10x times negative 3x squared plus 2. And that would be our final answer. Okay, so now we move on to the quotient rule. So here is the definition of the quotient rule. So basically, given two functions that are being divided, we first copy the denominator and then multiply it by the derivative of the numerator. Okay, then subtract. Then we just copy the numerator and then multiply it by the derivative of the denominator. Then Then after that, we set a denominator. Then it's basically the denominator squared. So if that sounded a bit overwhelming, let me help you. This is something that you should know, which makes this thing, which makes remembering this thing or rule so much easier. So it is log de high minus high de low over law squared. So basically what this means is that low or the denominator times the derivative of high minus high times the derivative of low over low squared. So low and then high. So again, low times the derivative of high minus high times the derivative of low over low squared. So it's way easier if you use this memorization technique. So let me demonstrate you just that. So number one, oops. Number one, we have y prime, oh sorry, y is equals to 2 over 2x raised to 4 minus 5. So y prime is equals to, so first, log the high. So log the high. So that means we copy the low, minus 5, then get the derivative of high. And since it's 2, we will just, the derivative is just 0. Minus high, so low, so high is just 2 minus, or rather, sorry, minus high times the derivative of low. So we just get the derivative of low. So that is just 8x cubed over low squared. So 2x raised to 4 minus 5 squared. So y prime, simplify it. We have, this is just 0, so we cancel that out. So negative 2 times 8x raised to cubed, that is just negative 16x cubed over 2x raised to 4 minus 5 squared. And that would be our final answer. Okay. So now let's move on to the next problem. Number 2, we have y is equals to 4x raised to 5 plus x squared plus 4 over 5x squared minus 2. Okay. So again, low. So we just copy low. Low the high minus high the low over low squared. Just a reminder. So low 5x squared minus 2 times the derivative of high. So that would be 20x 4 plus 2x minus high. So 4x raised to 5 plus x squared plus 4 times the derivative of low. So it's just going to be 10x over low squared. So 5x squared minus 2. Okay. Normally you would simplify this, but I will consider this as our final answer since a lot of math professors would pretty much prefer you to leave it as a piece like that since they don't want to give you a hard time. So just a reminder. So again, this is our final answer. Okay. Now, let's move on to our next problem, and that is number 3. Y is equals to 3x raised to 4 plus 5x cubed minus 5 over 2x raised to 4 minus 4. Again, low the high minus high the low over low squared. So low, so y prime is equals to low times times the derivative of high. So 12x plus 15x squared minus high. So that is going to be 3x raised to 4 plus 5x cubed minus 5. High derivative, high the low. So times the derivative of low. So it's going to be 8x 3 over 2x raised to 4 minus 4. Then let's just simplify this part. So that would be, let me just copy this. Okay. So let's distribute the 8x cubed right here into this part since it's not that hard to do. So 8x cubed times 3x raised to 4, that's going to be around 34x raised to 7. Then we have plus 8 times 5, that's around 40x raised to 6 minus 40x cubed. Then we distribute the negative sign to the parentheses. So let me just copy this thing again. So now we have negative 24x raised to 7 minus 40x raised to 6 minus plus rather 40x cubed. And that is our final answer. All right. So now the last derivative rule we have is the chain rule. So basically, if a function is inside another function, what we can do is first we get the derivative of the outer function while leaving the inner function as it is inside the outer function. And after that, we multiply that with the derivative of the inner function. All right. So again, the chain rule is basically something like this. First of all, we get the derivative of the outer function and then leave the inner function as it is. And after that, we multiply it with the derivative of the inner function. So let me show you what I mean. And here are some of the, here, the derivatives of the trigonometric functions, which will be used later, since getting the derivative of something trigonometric requires the use of the chain rule. So let me show you what I mean. So first we have number one, y is equals to x cubed plus 3 raised to 5. Okay. So one way to do this is to simply multiply itself 5 times, but who knows? Can you do it? No, I don't think I can do it either. So we can say that this is our inner function, okay? And this is our outer function. So what we can do now is to get the derivative of the outer function first. So first of all, bring down the 5. Then we leave the inner function as it is. So then raise to 1. And after that, we multiply it with the inner this time. So with the derivative of the inner, okay? So now that would be x, 3x cubed. All right. Now, after getting the derivative, we can now multiply them. But so y is equals to 3x squared plus 5, or rather, sorry, multiplied by 5, that is 15x squared times x plus 3, x cubed plus 3 raised to 4, and that is our final answer. Okay. Now, let me show you another problem where the chain rule is very helpful. So let's say we want to find the derivative of a trigonometric function. So of a function that involves trigonometry. functions. So in this case, we have f of x is equals to sine of 2x cubed. Okay. So in this case, our outer function is the sine function itself. And then the inner function is our 2x cubed. 2x cubed. Okay. So let us look back at what I wrote here. So the derivative of sine is cosine. So let's do that. So f prime of x is equals to cosine. Then remember, we leave the inner function as it is. So 2x cubed plus, now we get the derivative, or rather, sorry, multiply it by the derivative of the inner function. So that would be 6x squared. So the final answer is 6x squared cosine 2x cubed, right? So for our last example, we have y is equals to secant 4x raised to 5. So let us look back again at our derivatives of trigonometric functions. So secant, that is secant x tangent x. So what we can do now is y prime is equals to secant x. So we just leave the inner function as it is, multiplied by tangent x. Again, we leave the inner function as it is, times the derivative of the inner function. So that would be, so since that is our inner function, that would be 20x raised to 4. So our final answer would be 20x raised to 4 times secant 4x raised to 5 times tangent 4x raised to 5. All right. So that would be all for this tutorial. Thank you for listening and have a nice day. And please practice a lot. Practicing a lot helps in any math subject. So thank you so much and have a nice day.